Guys, you might want to have a calculator, and in fact, I'm not going to say might, you will want to have a calculator handy today. And I want everybody to get into their calculator, whatever they're using right now. And the first thing I want you to do is this. First thing I want everybody to do is this. I want everybody to punch in sine of 90 degrees in their calculator so I know that you're all in the right mode for this today, okay? Everybody's answer should be 1. If you don't get one, raise your hand. I'll come around and help you. When you punch in sine of 90, you should get 1. Everybody good? Got it, Caitlin? Yeah. Got it? What'd she say?
She said she needs to get a calculator.
Don't you have one in that iSmartphone?
Yeah, but I press it and I press enter.
Press 90. Press 90 first.
90 and then push oh. Okay, hold on. 90. No, just push that. No, see the answer. Okay, yeah.
Good?
Yeah.
Did everybody get 1? Anybody having trouble with that? Okay. Then we're good to go. Guys, this section, I'm going to guess, some of you may have talked about this a little bit before in prior classes, so it could be kind of a hit or miss. Did anybody ever have integrated 1 with me? Cole did, didn't he? You had integrated 1 with me, didn't you?
Oh, yeah.
Yep. Good days, right? Good times. You've probably seen this then. So here we go on this, guys. Section 5.5 is going to talk an awful lot about right triangles. Thank you, Brandon. Yep. Have a good day. All right. Your right triangles, just keep in mind, we're always talking about triangles where one of the angles is going to be 90 degrees all the time. So a couple things to keep in mind. If I'm dealing with a right triangle, don't forget about your formula, a squared, b squared, c squared, all right? But in right triangles right here, it's written up here, sine, cosine, tangent, cosecant, secant, and cotangent can only be applied to what kind of triangles, guys? Right triangles, all right? So they can only be applied to right triangles. And it says as long as we know we have a right triangle, we can use them to solve triangles. In other words, we're looking to find all the known angles and all the side measures, all right? Now, in any triangle, especially in any right triangle, when we're talking in trig terms, this is going to be really important to us. The example that I have right over here, where this triangle is set up, you might want to put a highlight by this or make sure you understand it. But in any right triangle right here, notice that the capital letters are always my angles, right? All right. Guys, notice where angle A is down here. See where angle A is down the bottom left? All right. We always say that a side is opposite of an angle when the uppercase and the lowercase letter match. So if you know what an angle is, then its corresponding side is actually going to be opposite that. So do you guys see how side A is opposite of angle A? In other words, this side A, is this side A even touching this angle? It isn't it? See how side B down here is opposite of angle B up here? Here's angle B. Does side B touch angle B? You guys understand what I'm talking about there? Okay? So the side is always going to be opposite of the angle that they're talking about. Everybody make sense out of that? Okay, so here we go on this, guys. In this triangle right here, I'm going to back these up quickly. Our job is to solve this triangle. And we're trying to find all the angles and the side measures, and I'm going to guess that we're going to do a really nice job with this. But in this triangle right here, you have some information that's known. What do you know already? Okay, A is 20 degrees. Now keep in mind, what kind of triangles are we talking about?
Right.
So the assumption is probably that angle C down here is what kind of an angle? So what could I plug in right here? 90 degrees, couldn't I? Okay, do we know any of the side lengths? Side C is what distance? 35, right? So if I know side C is 35, we really now are left to find angle B, side A, side B. Okay? So in this situation right here, Is there an easy way to figure out angle B? Has to be 70 because all three angles are going to add up to how many degrees? 180, right? Going to add up to 180. So if I add these two values together right here, what's 20 and 90 going to add up to? Well, it's 110. 110 from 180 would be what value? 70 degrees. And I believe that that's written right down here at the bottom in our notes already, isn't it? Says there's enough information to find the rest of the side and angle measures using trig. And keep an idea that a squared plus b squared is still equal to what here, kiddos? C squared. Okay? All right. I don't want to get too ahead of myself right here, but do you understand all the angles right here? All right. You guys are okay with that? You understand the angle part of it? Okay. I'm not going to talk too much about this right here. I don't like the way that the notes are written for this part right here. So what I think I'm going to do is I'm going to set up something different here to help you find A and to help you find B. So even though this kind of tells you what to do to find side A and side B, I think there's a better way to do it to see it better. All right? So here's what I'm going to do. I'm going to put some work over here. You guys might want to kind of split this a little bit on your paper. And up top, I'm going to write down that we're going to find side A on the left and find side B on the right. Okay? You guys okay with that? Have you got enough room to write there? Yeah. Okay, here's what I'm going to do. I'm going to make a bigger triangle on a separate sheet of paper, and we'll kind of do this chart right here. But give me a second to do this quickly. So here's my triangle that we had. Oops. Okay. Let's see. Angle A was down here, right? This was C, wasn't it? This was B. We know that this length up here is 35. Is that correct, gang? Yeah. Angle-wise, we had said this was 20 degrees down here. We had said this is my right angle. And we had said that B was, we were able to find B to be 70 degrees, right? Everybody agree with what I've got diagram-wise compared to what's on your notes at this point? All right. So we got to find side A, or little a, if you will. And we've also got to find side B, or little b. All right. Here we go. Let's find A first. Guys, where's side A? What segment is side A? From where to where? B to C. This is side A, right? Okay. Guys, I always tell kids that when we do this stuff, always pick a reference angle other than your right angle, okay? Besides the right angle, what angle was given to you? The 20-degree angle. Let's use that. I always tell kids, circle that reference angle. Basically, that reference angle is telling me, you know what, you're standing right here. This is where you are, okay? When I say, hey, here's a 20-degree angle, you are standing at that point A, all right? It's not me yelling for once. That's good. All right. Watch it. All right. Side A I got to find. Here's the deal. How is side A related to this reference angle that I'm at? It's an opposite leg, isn't it? So I'm going to label this as an opposite leg. Now, is there another length that I know in this triangle that's not a variable? In other words, do we know the distance of a certain side at all? I know what the hypotenuse is, don't I? Side C is what distance here? That's the hypotenuse. So here's the deal. Guys, we're looking to find this length A right here, which is what kind of a leg? Opposite leg in reference to this 20-degree angle. Okay, hear me out on this. Which of the three major trig functions is going to allow us to involve an opposite leg that we're looking for and a hypotenuse that we know? The sine. Okay? So here's what we're going to do. We're going to set up the sine function for this. And we're going to say the sine of our angle, that is our reference angle. What is the measure of that reference angle? Where are you standing at? 20-degree angle. So I'm going to say the sine of 20 degrees. All right, here we go. That's going to equal, by definition, for sine functions, your opposite leg, which is which variable? It's A, right? Over the hypotenuse of what value? 35. Whoops. Okay, now quickly, gang. Watch what this is going to do. Remember when I said in the beginning, make sure your calculator, when you punch in sine of 90, you get what value? 1. Do me a favor. Give me the sine of 20 degrees and give me that to 4 places. So you're going to get a decimal. It's going to be an ugly decimal. But I want that decimal to 4 places. 3420. I'm going to replace this trig function. Sine of 20 degrees is some number. It's some value. In our case, it's 0.3420. Okay? This is going to equal what over what, guys? A over what value? Okay, all I've done is taken the trig function, the sine of 20 degrees, and turn that into a decimal equivalent. Okay? Now, I'm a kind of a guy that likes to work proportions an awful lot. I think cross multiplying and dividing is probably the easiest thing in the world, isn't it? If I could just say, hey, here's a worksheet on proportions all year long, would you guys do it? You all know how to multiply and divide, right? Right? I'm going to take this decimal and put it over a 1. I always set a proportion up like that because it just helps me visualize that I'm going to go to solve this. Take 0.3420 times what? Cross multiply times 35 and divide that by what? 1. Okay? To the nearest tenth, what do you get when you solve that?
11.9.
So my A value is 11.9.
No, it'd be 12. My bad. Because it's 9.7.
Okay, I don't care if you go 2 places, 1 place. Nearest tenth is typically good. What do you guys get for that? 12, 11 point?
Here.
11.97. I'm just going to round it up to 12. Is that okay? Okay, real quickly, guys. See if you get 12 in that one. Okay. All right. Guys, does it make sense that this distance A would be shorter than 35? Because in a right triangle, isn't the hypotenuse going to be the long side? It is, isn't it? Okay. All right, so here's a question. Side B is down here. Guys, if you're standing right here, how could I find side B? What can I set up if this is what I'm looking for? I'm trying to find side B. I'm standing here, and I know that this length is 35. Why cosine? Who's talking? I can't find. There you are, Jaden. Go ahead.
Cosine of 20 is equal to B over 35.
Yep, she's saying let's use cosine because how is B related to my reference angle? It's an adjacent leg, and we know the hypotenuse. Let's see, adjacent leg, hypotenuse. Cosine, right?
Wait, why are we doing that? Can we just use
Yeah,
A
you could
squared
choose
equals
A.
B?
Oh, you could now if you wanted to.
Oh,
We could if you wanted to.
Or you could use the sine of
I could use tangent also. I could go the tangent of 20 degrees is now equal to 12 over B, couldn't I? Ho, ho, ho. I had a teacher in school who used to say this, and I used to get so frustrated by this thing, but I'm going to say it anyway. There's more than one way to skin a cat.
okay.
You heard that before? Anybody ever heard that? What the hell?
What about
Why would you skin a cat in the first place? I don't get it.
Because you're gonna eat it.
It's just going to shed. All right. Yeah, Jace, I don't disagree with you. If you want to go Pythagorean theorem after that, cool. I don't care. All right. Why don't you do Pythagorean theorem real quickly? Go 35 squared minus 12 squared and work that out and see what you get. And let's see if we agree on this. All right. I'm going to go the cosine route like Jaden said. All right. I'm going to say the cosine of 20 degrees. Now, does everybody understand why she chose cosine?
Could you also do the sine of 70 since you
I could do sine of 70. You bet. Okay. If you want to use that 70-degree angle, you betcha. A lot of ways to do it. Cosine of 20 would equal the adjacent leg. What is the adjacent leg to your reference angle of 20 degrees? Well, it's B, isn't it? Over the hypotenuse of 35. Jace, you got an answer, kiddo?
Yeah,
What'd you get?
32.8 or 32.9.
32.9, we'll call it? I'm going to see if we agree, okay?
What'd you get?
Somebody cosine 20 out to 4 places for me.
0.939?
0.9396.
7.
I'm going to put that decimal over a 1 because I like proportions. That's just the way I work. All right.
Nice.
Did I write that correctly?
It's point nine.
You can do 7, because it's 93969.
9396. I just chop it off. 97. When we start getting down to what, tenths, hundredths, thousands, we get down 10,000s, we're in the park. Okay. Somebody cross multiply that out and divide for me.
It's 32.
32.9. Okay.
But it's a different answer than what you do if you did Pythagorean theorem.
Yeah, it's like a
I did
couple
them both.
decimals off.
Yeah, it's decimals off. Why is that?
Rounding.
It's all rounding. How far off are you?
Not a whole lot.
It's going to be a tad bit different simply based on however you round. Okay. And if you look at we're off only by what, a hundredth,
Yeah, it's not a big deal.
11 thousandths. We're off by 11 thousandths. So, yeah, as long as you're in the park to the nearest 10th, I'm happy with it. So, 32.8, 32.9, you found both two, right?
Yeah.
So we're good to go. All right. Very good. Very good. Questions on what I've done here so far? I get the feeling that we should have maybe seen something like this before. I hope anyway. If we haven't, okay. Let me go back to my original page here then. I want to fill these values in. Do you guys have down what you need right there? Anybody need more time with this? Okay. Back on the first page then. Help me fill this stuff in. What was our A value then? What did we round to? 12. And what did we say the B value was? 32 point. And it makes sense. And you know what? We're pretty sure we're right because 35 was the hypotenuse, wasn't it? So both my answers, if we're looking for legs, had better be shorter than what value? 35. Okay. So again, it says don't round angles to the nearest minute. Just go to the nearest tenth of a degree. I'm fine with that. Okay. If you go two places, that's fine. Understand, I'm more worried about how did you find it instead of being exact most of the times. Unless on a quiz or test, I tell you that. If I tell you that on a quiz or test, but understand that nearest tenth will be good enough. Okay, let's go to the second page and look at some stuff here. There's some interesting stuff on this. You're going to start hearing some things term-wise that are going to relate to some real situations here. Things like angle of elevation and angle of depression. And they're always going to be measured from what we consider a horizontal line. So here's the dealio. If you were on the balcony of the house here, wherever you're doing, maybe you're up there putting Christmas lights up here, okay? You have an eyesight right here, all right? And that's that horizontal line. It's basically you're looking straight at the horizon, right? So if I'm looking down on something, what kind of angle do you have here, gang? Angle of depression. And they talk about the distance for line of sight. Your line of sight is from your eyeball to where an object is. So do you understand these terms right here? Okay, if she was looking up, what do you think that angle is going to be called? Angle of elevation. Natalie, what's so funny? Okay. Same thing here. If you're on top of the building, all right, man, that's a big, looks like King Kong on top of the Empire State Building. It's pretty big.
The car is just about
Car's about the size of the building, man. Oh, it says diagram on the scale, all right? Let's get that cleared up right away. Understand the angle of elevation. Again, here's your horizontal to look straight out here, okay? I'm not going to say anything because I'm just not going to say anything.
Say it.
No.
Do it.
I've never looked really closely at this drawing before, but something that makes me laugh here. All right, I don't know why that's there. There's your angle of elevation right there. Oh, I need to time out here. Let's try an example here. All right, it says you look at a boat from the top of a high cliff. Okay, so we're at the top of this cliff. The angle of what? What are we talking about here, guys? Angle of what? Okay, so let's maybe start a sketch right here. We know we're going to have some kind of a horizontal line, don't we? Isn't that going to be your horizontal right here? Okay, I'm going to work from left to right. So it says the angle of depression is 30 degrees. So I'm going to say from here to here, what's this angle have to be right here? This angle has to be 30 degrees going down there, all right? It says that you can tell the boat is 600 meters away because it's by a buoy. How tall is the cliff? All right.
So it's like 600 right from the cliff or from you?
We're talking about our line of sight. So from where I'm at, you can tell that it is 600 meters away. Now, I don't think that they're going to measure 600 meters from where you are on a line of sight. Do you agree with that?
Like the
So it's going to be like from where you are relative to the ground horizontally. Does that make sense?
Yeah.
So where do you think the 600 is going to go? On our horizontal or on our line of elevation?
Horizontal.
Okay, or our line of sight, I meant. Okay. We need to then find the height of this cliff right here, right? You guys agree with that? And maybe
The triangle's the other way.
maybe my triangle should be drawn differently here.
But
You're standing on the cliff, right?
Yeah.
So let's just say the cliff is here. And you're standing on top of it, all right? You guys agree there? It says we have an angle of depression of how many degrees? So we're going to assume that here's a horizontal line going across right here, right? So my angle of depression would be 30 degrees related to a horizontal, wouldn't it? So it's going to look like this. This would be 30 degrees right here, right? Which would make, it's still going to be the same thing. You're still going to get the same answer. The distance from the buoy to here is how many feet again? 600, right? Guys agree with that? We want to know how tall the cliff is that we're standing on. Well, think about it this way, guys. Isn't this my right angle right down here?
Would the top angle be 60 then?
Top angle would be 60 degrees, right?
Yeah.
Okay, here's the deal on this. What's that make this angle down here? Okay, just check this out. Isn't 30 degrees opposite the cliff height we're trying to find right here? We're trying to find the height of the cliff, so I'm going to call this H. Now, even though I totally messed up the drawing in the beginning, wouldn't this have really been the cliff height right here? Isn't 30 degrees opposite that cliff height, like it is down here in the better drawing? You guys agree with that? Okay.
So the horizontal level 600.
Anytime they talk about it, if they say a line of sight distance is such and such, then it's your hypotenuse, okay?
But it just says it's.
Yep. The assumption is this, Jay. So you're standing on this cliff, and there's probably water down here, right below that cliff, and that buoy out there probably says something like 600 feet on it, okay? And that buoy is going to be measured on the surface of the water.
Yeah, they wouldn't. Okay.
That makes sense. They wouldn't measure from clear up top where they are. They measure it from the base where the water meets the cliff. You okay with that, bud? Okay, so you agree my horizontal should be 600 there? All right, so what are we trying to find here, gang?
The height of the cliff.
Height of the cliff. We've got some reference angles to use other than the 90-degree angle. Let's use a 30-degree angle because they gave that to us in the problem. Is that okay? So I'm going to reference my angle at 30 degrees. I'm going to reference my angle at 30 degrees. All right, give me a second. I'm going to get rid of this drawing over here to make some room. All right, let's work this out. Guys, if this is where we're at, reference angle right here, H is the distance I'm trying to find. How is H related to my reference? Opposite leg. And then I also have another distance of 600. How is 600 related to that reference angle? It's an adjacent leg, isn't it? So let's see, opposite leg, adjacent leg. Which of the three functions would I choose to use? Tangent. So I'm going to say the tangent of, whoops. I'll say tangent of, what's my reference angle again, gang? 30 degrees is going to equal, excuse me, H.
0.57.
It's going to equal H over what? Opposite leg of H over the adjacent leg of 600, right? Okay. So how about my decimal equivalency for tangent of 30? 0.5 something, isn't it? 0.58. Go two more places. 5.8.
5773.
5773. For some reason I knew that. Okay, now we can just cross multiply and divide. 346.41. Okay, so about 346.4 feet tall. Okay. Any questions about what I've done here? Guys, we're dealing right triangles. Strong suggestion. Anytime you see a story problem, draw a what? Draw a picture. Okay. Draw a picture. All right. Any questions on that example? Anybody? Okay, last page, last page, last page. I'm not going to get too excited about this last page, but it's kind of a drawing here. Does our drawing match what they're talking about right here? Did it match what we're kind of talking about here? This one here went a little differently. It went this direction and in this direction, but weren't we working with the triangle below? Same thing, right? Same exact thing. So just kind of understand that when you set these drawings up, I had a really bad one to start. One that was more for the picture. The way they're going to do this one, they're going to call this 30 degrees. They would have called this 600. And they would have called this distance, which is the height of the cliff, your H right here. And you would have still done the same thing. You're at 30 degrees. You got an opposite leg, adjacent leg. Again, you would have gone tangent of 30 degrees equals H over 600. Could have used 60 degrees if you wanted to. You bet. You bet. Say you wanted to use a 60 degrees. Suppose 60 was right here, and this was 600, and this is the H you wanted to use right here. Same exact thing. You would have gone tangent of 60. In this case, this would have equaled, what's opposite 60 right here, Kaylee? What's opposite of the 60 degree angle down here? 600 over the adjacent leg to 60, which would be your H. Okay. How you guys feel about this? You okay with this? Hope so. Okay. Any questions to this point? Any questions to this point? Guys, one other thing I wanted to tell you about is this. You're going to see a word in your assignment, which is called an. Anybody know what this word is? It's called apothem. And an apothem simply is a line segment from the center of a shape to the midpoint of one side. Okay? Basically, here's your center. It's a distance from here to what point down here? To the midpoint of one side. So if you ever see that term, just know that that term simply means a distance from the center of the shape to the midpoint of the side. You okay with that? All right. You guys have questions for me at all? Any questions at all?